So a review of compound names and formulas from first year. Ionic compounds contain a metal plus a nonmetal. So you have a positive cation metal combining with a negative anion nonmetal, or you might have a plus or minus polyatomic ion. The total ion charges have to equal 0. It has to be a neutral compound. So if you have a +1 and a -2 ion, you can't have a 1-to-1 ratio because the charges would not cancel. So you would need a second of the +1 ion so that your total comes out to 0. So you can't write the formula unless you have a 0 charge. Roman numbers are used to tell the charges of transition metals. Copper can be +1 or +2 because it can lose its outer s electrons and then some of the d electrons. So copper Roman number 2 indicates a copper +2 ion. Quick review on ion charges. You'll do an electron configuration sheet later in the packet. But potassium has one outer electron, and if it would lose that one electron, it would go back to the configuration of argon, which is an octet, much more stable for the atom. And so if this electron is lost, potassium becomes a +1. +1 because it had 19 protons and 19 electrons, and if you take off that one electron to get back to an octet, you have an overall +1 charge. Oxygen is closer to an octet, and so it really doesn't want to lose electrons. You'd have to take off all 6 of these second-level electrons. It would be much easier to gain 2 electrons, and so oxygen is going to take in 2 more electrons in the p orbital. And if that becomes p6, then you have an octet, s2p6, and oxygen has a -2 charge because it had 8 protons and 8 electrons, and if it takes on 2 more electrons, you have 10, and that gives you a -2 charge. So potassium has a +1 ion, O is a -2, and so those charges don't cancel to 0. You would need another of the potassiums, and so your formula would be K2O. Calcium is +2 charge. Nitrate is polyatomic -1. That doesn't cancel, so you need another nitrate. You need another of whichever is your lesser charge overall. And so remember the way we write polyatomics is we do parentheses 2. Iron, they tell you the Roman number is 3, so the iron on this, the charge on this atom is +3, and hydroxide is -1. So you need some more negative charge, a total of 3 hydroxides. So your formula would be FeOH parentheses 3. To name the compounds, BaBr2, first word is barium. We don't change the endings on the metals. But for the nonmetals, we do change the ending from INE to IDE. So instead of bromine, it's bromide. We don't need to say barium dibromide because the 2 comes in, the subscript 2 is about the charge difference. Barium is +2, bromine's -1, so you need 2 of the bromines to cancel the charge. So in ionic compounds, we do not show prefixes. The next compound is 2 polyatomics in a compound. The first one, NH4, is ammonium, and then the second is carbonate. And we don't change the endings on the polyatomics. Whatever they are on your polyatomic list, that's what they stay. The next compound contains a transition metal, so we are going to need a Roman number. So the name is copper oxide. We're changing oxygen to oxide. Nonmetals always end in IDE. But we do need to know the Roman number. We need to know what the charge is on each of the coppers. We know that O is -2, and we know that the 2 coppers have to balance that. So if our total negative charge is -2, the 2 coppers would have to come out to +1 each, so you'd have a total of +2. So when we do a Roman number, it's the charge on each one individual copper ion. So in this case, this is copper 1 oxide. Covalent compounds involve nonmetals bonding to nonmetals. There are no charges in these compounds. It's all about electrons being shared between atoms to make single, double, or triple bonds. Acids are also in this category because they have a hydrogen covalently bonded to the rest of the acid, which we're indicating here with an A. So acids have the generic sort of formula HA. Prefixes are used because there are no charges to help you figure out the formula. You sort of have to be told in the name how many of everything there is in the compound. So carbon dioxide would be CO2. They technically should say monocarbon dioxide, but we tend to drop the monos and just use everything from 2 on. The reason we have to use prefixes is that sulfur, for instance, can make more than just two bonds. You could see how these single electrons could bond to some other atom, say a chlorine, and make SCl2. But you can use some energy and actually unpair these two electrons, these two p electrons, and then you would have four singles, and you can make the compound SCl4, and you could also unpair this S pair. And you'd have six single electrons, and sulfur could bond 6 times with chlorine. So sulfur and chlorine actually can make 3 different formula compounds. We'll call the first one sulfur dichloride. The second with 4, tetra is 4, so we're going to say sulfur tetrachloride. And the last hex is 6, so we'll call it sulfur hexchloride. And so the prefixes tell you exactly how many of each element in the compound because we can't figure it out from charges. There are no charges in covalent compounds. It's all about bonding electrons. So if you hear the compound sulfur trioxide, you have 1 sulfur. Trioxide means that you have 3 O's. So they're just telling you the formula in the name with the prefixes. The next compound, phosphorus, we're going to say P. Pentachloride, so we know that there are 5 chlorines. You can have more than one of the first element also, so if you have dinitrogen, that's N2. Tetraoxide is O4. And in AP Chemistry, we'll be drawing some of these compounds, so you'll see how they actually conform. To name the compounds, once you determine that they're covalent, you do that because there are 2 nonmetals. BCl3 is just boron, and again, we don't change the name of the first element. And then there are 3 chlorines, so we say chloride. We're still going to change the nonmetal, the second nonmetal, to IDE. The next compound is SCl6, so we're going to say sulfur. And because there are 6 chlorines, we're going to say hexchloride, or you can say hexachloride if it sounds better to you. Either one is correct. And the last one is oxygen. And then we're going to say 2 chlorines, so we're going to say dichloride.